Welcome, everyone. I'm Tracy Fitzpatrick, and I'll be your moderator today. Thank you so much for joining us here at Netcom Learning, a market leader in promoting lifelong learning, training, and talent development solutions.
We are very excited to host today's event, How to Develop Apps That Scale Google App Engine. Presenting today's topic is Geetika Sethi. Geetika is a Google Cloud authorized trainer and author with over 13 years of training experience. She has various certifications in cloud computing for Simply Learn and other coveted certifications. With over 1,000 testimonials from learners around the globe, she has a proven track record of excellence, and she has a commitment to the advancement of technology and innovation.
Now, please bear in mind that this is an overview of a very robust topic. We offer a collection of technical and business courses that can be tailored to your specific requirements. If you are interested in a further discussion, you can make an appointment with our learning consultants through our website at netcomlearning.com. Today's session is also being recorded, so you'll get free access to the recording in the next 24 hours via email. Netcom Learning helps customers build innovative learning organizations by achieving a smarter workforce, adapting to change, and driving growth. We do this with a broad catalog of offerings, developing customized learning plans, and our global delivery capabilities. Since 1998, we have been empowering organizations with our managed learning services to help them reach optimal performance results and address challenges. We do have 9 practice areas in which we specialize. They encompass people, process, and technology training. Today's presentation is from the Cloud Practice Area. Netcom Learning offers a comprehensive training portfolio of courses for the topic being covered today. Our upcoming classes include various trainings on the given courses. You can also access a variety of marketing assets, such as the free training and blogs, by clicking on the available event handout. These offerings can be found with a simple search on our website at netcomlearning.com.
Today's session will cover the groundbreaking capabilities of Google App Engine capabilities in automatically scaling web applications based on demand and its transformative potential. This masterclass has been designed to equip you with the skills and knowledge to create scalable web applications effortlessly using Google App Engine. In addition, participants will gain practical insights and a clear roadmap of the App Engine's capabilities and limitations to enhance existing applications or evaluate App Engine for future projects.
And now I would like to give you a quick overview of the logistics before we get started. To begin with, you do have the option to view in full screen by clicking on the full screen button on the right side of the GoToWebinar viewer. Simply hit the escape key to exit the full screen. Everyone has been muted except for our presenters. Feel free to submit any questions you have for the presenters here in the questions pane, and we will address them at the end of the session. And to get the best out of today's events, we've included the slides, courses we talk about, and marketing assets in the handouts section of your GoToWebinar viewer. You may refer to them at any time to get a better understanding of today's topic. And we do realize that some of you may have to leave early and want to let you know that as you do leave the session today, you will be presented with a short survey. We would like to request for you to take a quick moment to participate in that survey. Your feedback really helps us understand your learning experience and improve our future sessions for you. The survey answers are measured on a scale of 1 to 5, 5 representing outstanding and 1 representing poor. And now I'd like to pass this over to our trainer to present today's topic.
Hey, Geetika, thank you so much for joining us today.
Hi, everybody. A very, very warm welcome to today's webinar on how to develop apps that scale with Google App Engine. And I would like to introduce myself as Dr. Geetika Sethi. I'm a data scientist and a cloud computing professional with experience of 13 years plus. And it just somehow turned out that I was fortunate to be trained at Google Seattle. At the very first time, I actually got exposed to GCP. And throughout the years since then, it has been an amazing journey with Google Cloud Platform. And I'm here to share my few pieces of knowledge with all my learners. And I hope it's going to add value. So let's move forward to today's agenda. We are going to be looking at introduction to Google App Engine. We are going to be looking at the scalability features offered by App Engine, an important set of information typically for the users of App Engine. Also, how we are going to be looking at typically deploying of autoscaling web applications, which we may not dive very deep into developing, because our agenda here is not the development and programming, but our agenda here is to be able to use the Google App Engine. So learning that is going to be important. And then we're going to take a look at evaluating App Engine for our use cases. Typically, under what real world scenarios do we implement Google Cloud App Engine in our projects on day-to-day basis? So let's move forward. I'm super excited for this session and this webinar, and I hope my learners are excited too. So let's take a look at the introductory background information about Google App Engine. Google App Engine is a platform as a service. That means it has already inbuilt infrastructure already in place, and hence that is called as platform as a service. All what it does is it helps us to deploy our solutions in an easily, readily manner because the infrastructure is already provisioned. So we are able to deploy and host our web applications on Google App Engine because of its ability to help us to do so. Secondly, it is built on Google's robust infrastructure. This information is very important, and downstream we will see how it adds to a value to entire journey of the development and deployment on Google App Engine. So the Google's robust infrastructure means around the globe, Google's data centers are widespread, and they're also interconnected to give global outreach to our solutions that we deploy. And in this session, the solution we are going to be focusing on are web applications. So web applications means applications that are accessible on the internet. So throughout the globe, throughout the world, we want these applications to be reaching out to the users who are going to access our solutions. Then we are going to also learn that the Google App Engine platform offers automatic scaling, managed services, and a variety of programming languages. Okay, so let's learn what is automatic scaling. Automatic scaling typically means increase in resources in an automated manner. So in this example of using web applications deployment on Google App Engine, we typically mean the automated scaling is to increase the number of resources needed at any given time. So let us try to understand this a little bit better. Okay, so now going back to where we were, we are taking a look at what do we mean by automatic scaling and how is it important for our discussion about hosting web applications in Google App Engine. Before we understand automatic scaling, it is important for us to understand the concept of scalability. So scalability typically means the increase in resources. Let us take a hypothetical situation about an e-commerce web application deployed on Google App Engine. Now, this e-commerce web application is bound and is expected possibly to experience the increase in shoppers, let us say, during the Christmas time. So during the Christmas time, or maybe soon after Thanksgiving and around Christmas or November, December, we are going to be able to experience high traffic spikes for this particular traffic spikes for this particular e-commerce web application. And hence, this e-commerce web application, which is deployed on the given infrastructure, has to accommodate these spikes. In order to accommodate the spike of operations and spike of users and shoppers, there needs to be the increase in the underlying resources. For example, the storage may have to increase. Another example is the number of machines on which this application is deployed may have to be increased. So overall, this increase is called as scalability. And there are two kinds of scalabilities. The first category is the vertical scalability. The increase that is going to happen on the same set of resources or on the same given resource is going to be covered under vertical scalability. So let us say, for example, the web application, which is an e-commerce application that is deployed on a given machine or a virtual machine instance or on a given computer or an instance or a virtual machine instance, whatever you want to call it as, in the GCP system or in the GCP environment, that particular machine or that particular VM is going to have its own storage or its own drive. So let us say in the beginning when the application was launched, it had, let us say, up to 100 GB of storage that was being used. But now, with a spike in traffic during Christmas time, the requirement of storage has increased and it is going to be set up to, let us say, 500 GB. So what we are looking over here at is that the same drive, which was 100 GB, is now 500 GB, and there is an increase in the particular configuration setting of the same resource. And whenever there is an increase, there is scalability. And this type of scalability, my dear learners, is called as vertical scalability. On the other hand, the second category of scalability that we are going to learn next is the horizontal scalability. So for horizontal scalability, there is the increase in the number of resources. That means copies of the same resource are created. So increase is there, scalability is there, excepting for the fact that we're looking at replicas or clones getting created. So that is called as horizontal scalability. So when we are using Google Cloud App Engine, we abbreviate it as GAE, this platform has the power to automatically scale up. So this use case, let us say, the consideration of horizontal scalability is applicable to the use case of the web applications being deployed, because whenever there is going to be traffic spike, say during the Christmas time, then there is going to be the increase in the number of replicas of the applications to which the traffic can then be directed to accommodate the spike, rather than letting the complete traffic access a given machine, and that is going to lead to the crash of the machine and a poor user experience, hence, or the poor shopper experience. Hence, the copies that are getting created or the automated scaling that is possible for these machines or the applications copy on these machines is going to help accommodate the increased traffic. So taken together, automated scaling is an important feature for the Google Cloud App Engine because it helps to accommodate the traffic spikes for the web applications that are hosted on this platform. Another important point is the managed services, by which we mean that on the Google Cloud platform, app engine that we are going to use to deploy our applications, it is part of the managed services. So managed services typically means that the operations of the platform itself is handled by the cloud provider itself. That is Google, right? So this means the infrastructure launch, infrastructure management, etc. is all taken care of by Google. And we, as users of Google App Engine, can focus on innovation. We make our solution better and better rather than looking at the infrastructure or looking at the operation of the infrastructure, etc. So managed services are the services where we as users don't have to worry about the underlying inputs. We are only focusing on making our own solutions better and better. So moving forward, the third important point is the variety of programming languages. So this typically implicates that on Google App Engine, there are multiple possible runtimes. So what do we mean by runtimes? That means that we can be having multiple possible languages that we can implement in our work. So based on our solutions, we can use Python, we can use Ruby, we can use Node.js, any language that we want to be implementing in our solutions. Majority of the commonly used and implemented languages are already available and the runtimes are available in Google App Engine environment. So taken together, this gives us the benefit of being able to implement our solutions in whatever programming languages, or even in fact, if we have multilingual solutions means that our solutions could be in multiple languages and not even in single language, but in multiple languages. Then we can be using variety of programming languages and their runtimes we can leverage on Google App Engine. So taken together, we are now moving forward to looking at the benefits of the Google App Engine. What advantages do they bring to our solutions? The list is as follows. Number one, faster development, increased scalability, easier maintenance, and reduced cost. Let's navigate through each of these and see how they bring benefits to our work and advantages to our work for hosting our web applications on Google App Engine. The first advantage is faster development. So let us see how Google App Engine contributes to faster development of our web applications, and in fact, not only development, I would say deployment and complete operations as well. So the first thing is that because Google App Engine is a managed service, we studied it in the first point, right? Introduction. It is a managed service. Why? Because we don't have to offer the infrastructure launches. So because it is a managed service, we do not have to worry about the infrastructure. Infrastructure like what? The examples include, number one, the machines, the virtual machine instances. Number two, the storage. Number three, your, let us say, your networking. So we really don't have to dive into the infrastructure setup, and hence we can focus on the code and making our web application better and better. The fact that the infrastructure handling is taken out of the picture, it leads to faster development deployment pipelines and of course improvised development deployment pipelines. Next, we are also able to leverage the pre-built services on Google App Engine. Why? Because Google App Engine is an environment that offers us collection of pre-built services that are highly helpful for web application deployment, essentially. So by leveraging those pre-built services, which are already in place and we don't have to go and individually arrange licenses for them, we are able to have faster development taken care of. Then the third important point is simplified deployment. The deployment of web applications on Google App Engine happens or occurs through CLI, command line operations. When we use command line operations with few quick commands, the readily developed application which has already been tested in the local environment can be deployed with only few commands. And that application can also experience scaling. And we have already discussed the scaling, like we discussed for an application which is going to experience high traffic during the Christmas time. The resources have to scale up, and hence, because Google App Engine has that inbuilt, the scaling systems being present inbuilt, that can also be experienced. But we will dive quite deep into this topic of scaling because that is the most attractive feature for the Google App Engine web applications hosting and deployment cycles. So let's go to the next advantage of Google App Engine, and that is the costing. Google App Engine big time gives us the advantage of having reduced costs for our work, and that is because it follows the model of pay only for the resources you use. It follows or adopts the model of pay as you go, and this is because the complete Google Cloud Platform enables the users to make the payments for the resources they have actually consumed in their projects and solutions. So for example, if we are going to launch the Google App Engine and deploy our application on Google App Engine through right protocols, we will see that one example in the demo today itself, in the session itself. In that scenario, we are going to see that for whatever duration the Google App Engine is going to be deploying our resource, our application, our solution, we are going to pay only for that particular duration and that set of resources which we are going to consume. And once we terminate our solution, we are no longer bound to pay because it is pay as you go model that the Google Cloud Platform adopts for all its services, including Google App Engine. The next important is service that contributes to reduced costs is automatic scaling. So we have discussed in depth just on the whiteboard what is automatic scaling. Automatic scaling means increase in resources automatically as and when needed. The example that we considered was the e-commerce web application during the Christmas time, right? So that needs a high number of resources and hence the feature of automatic scaling is present. But the question is, how does that adds to or contributes to reduced costing? And the answer to that is that it prevents over provisioning resources when they are not needed. That means that even though during the December Christmas time, the resources were provisioned, but in January and February or March, when the Christmas is over and the traffic goes back to its normal levels or lower levels, then the resources that were already provisioned are no longer in use and they are terminated and they're already taken care of because of the inbuilt automated systems of scaling and elasticity that are going to then contribute to the reduced cost. That means during the months of February and March, in our example, when the Christmas is over, the need for the resources is no longer there, and hence the costs are not going to be adding to the bills because those resources are terminated automatically and no longer in use, which were actually in use in the December time to accommodate the high shoppers or high number of shoppers or traffic spikes in the e-commerce web application, as an example. Also, Google App Engine offers free tier services. They may not be many in number and not a lot, but for quick testing purposes, the developers can leverage this feature to do quick initial experimentation without initial cost. And this overall is going to contribute to the reduced costing of web application hosting and deployment on the GAE, which is Google App Engine. Furthermore, the GAE is going to permit easier maintenance. Let's see how. The first point is that the Google, which is our cloud provider, which is offering us Google App Engine service, manages the underlying infrastructure because GAE is the managed service. It is a platform as a service. IaaS infrastructure is already taken care of, and hence the underlying infrastructure is not our responsibility. It is Google's responsibility. Hence, the maintenance becomes easy and the overall time, effort, energy can be spent on improvement of application and innovation. Also, the use of Google App Engine eliminates the need for manual scaling interventions because there are automated scaling interventions options available. Not that manual scaling is totally impossible, but it is not a preferred choice because automated scaling systems are present in GAE that automatically lets the increase in resources to happen to accommodate the change and, for example, the traffic spikes, and that is going to make our life easier, and hence the maintenance under such circumstances is highly reduced because there is no manual intervention needed. Automated systems exist and prevail and operate as and when needed. Also, the feature of versioning and rollbacks, which is available for our complete pipelines that we operate for hosting web applications, are going to enable easier maintenance because we don't have to then track the versions ourselves. It is the App Engine that allows to track the version in an automated manner. So taken together, we are able to leverage easier maintenance on the Google Cloud App Engine. Moving forward, we see that another advantage is increased scalability. So in this entire session, scalability is the central point of discussion because that is the exact important feature that attracts the developers around the world to use Google App Engine along with other features as well, but this being the major one. So moving forward, we see that the automated scaling that handles the traffic surges contributes to scalability. Now, why do we want scalability? Why do we want increased scalability at the very first place? And that is to increase our business, increase the revenue. So an e-commerce web application, which is totally generating its revenue from the business it does with the shoppers online, it definitely wants its application, that company wants its application to be having global outreach, and it wants it to be highly scalable so that it can be scaled out to wider audiences under different circumstances, and hence more revenue can be generated and it can turn out to be a profitable business. So increased scalability is possible on Google App Engine, of course, because of its automated scaling and automated scalability, and that is an advantage to the developers that use Google App Engine for their web application hosting and deployments. Also, there are flexible runtime environments. So let's remember the runtime environments include the different languages, different platforms you want to be using for your solutions. So you may use Python, you may use Ruby, you may use Java, whichever you want. There is complete flexibility. You can also use multilingual applications that can be deployed. And this having having flexible runtime environments and having so much available for the deployment possibilities, that adds to the scalability overall. And also this service itself, the Google App Engine, is integratable with other scalable services. So let us understand this point, because through this point, not only we are going to understand how this is advantageous and adding to the advantage of using the Google Cloud App Engine, but we are also going to talk about some architecture or solution architecture building for the requirements that we handle on Google App Engine. So let us understand this point in depth. So through this point, we need to understand that the Google App Engine is highly integratable with other services on GCP, Google Cloud Platform. For example, let us say the databases. So the databases are going to offer us additional storage and organization of the data that this application, which is deployed on Google App Engine, can actually leverage. Another example of the service that can be leveraged on Google Cloud Platform that can get integrated with Google App Engine is your storage service for your object storage services. For example, your buckets. So buckets are object storage entities, and providing the integration with buckets give additional storage capabilities irrespective of the data formats, and they're highly scalable. That means tons of data, up to, let us say, petabytes to exabytes of data can be stored over here. So our web applications, they can leverage the advantages of added services only and only because Google App Engine is very, very well designed to be able to get integrated with other services on Google Cloud Platform as well. So taken together, we have seen that in the first part of this discussion, we have quickly discussed the introductory information, and we have also discussed the advantages of Google App Engine. Now, let's go to the key features of Google App Engine. The list of key features of Google App Engine is actually very long, but in the want of time, let us discuss the 4 important features which may be helpful to the developers or the learners or the audiences participating in today's session. So now let's take a look at the first feature, which is automatic scaling. So we've discussed scalability, that means increasing the resources. We have discussed that can be handled in an automated manner. But now this feature of Google App Engine, automatic scaling, is going to allow to be able to cater to the use case of handling traffic surges. So that is one important use case. Another important use case to which this automatic scaling is going to cater is high availability. And likewise, there are so many numerous advantages of automatic scaling, and hence become an important feature of Google App Engine. The second one is your dynamic scaling. Scaling means increase in resources based on metrics. Now, this is very important. This is a new word we are introducing in this session, and that is metrics. So metrics is part of the monitoring system on GCP. So when the Google App Engine is monitored, the data is generated and presented through metrics. So if the data is showing that scaling is needed, let us say in the situation of traffic surge, then that is going to get accommodated dynamically. So that means Google App Engine constantly communicates in a feedback loop with its metrics and monitoring system to then give us the outcomes that are needed at hand. Also, the Google App Engine can get integrated with the scalable services. So other scalable services. So example that we discussed was the, let us say, database services. So one example of the scalable service we are going to consider is going to be buckets. So buckets on Google Cloud Platform can store the data unendingly, like for example, in a very, very highly scalable manner. So we may have, let us say, petabytes of data, exabytes of data, whatever amount of data we want to store, then that storage is possible with a bucket. So hence it is a highly scalable service. So the integration of the Google App Engine, which is holding our application, and hence integration of our application with the bucket as an example of the scalable service, gives added advantage to our solutions to be able to then leverage the added features of the Google Cloud Platform and added services of the Google Cloud Platform, making our solutions more advanced, making our solutions highly robust, and also making our developers being empowered with additional services in their solutions. Now, the next key feature is built-in services. So Google App Engine, although it can integrate with other services like we discussed in the previous point over here, but let us not forget that it has its own built-in services as well. Its own set of built-in services include databases internally into the internal systems, caching, memory caching, big time, because caching allows storage which lets you retrieve the data or lets the system retrieve the data as and when needed in a very time effective manner. So memory caching is what we're talking about here. And then the task queues, which are asynchronous systems or asynchronous tasks or operations that may happen or which may have to be done in an orderly manner. And overall, these are going to be adding value to our solutions that we deploy on Google App Engine. So taken together, so far we have discussed the two key features. Number one, automatic scaling. Number two, built-in services. The third key feature is security. So my dear learners, security is a big topic. So in the want of time, let us stick to 3 points, but we may definitely agree that these 3 points may not do the complete justice to the security discussion. But in the want of time, let us stick to these 3 important points. The first one is that the Google App Engine is secure by design infrastructure. So what do we mean by secure by design? The infrastructure like compute, the storage, the networking that goes into Google App Engine operations and are part of the fully managed implementations on Google App Engine that Google handles on its own, and it is not the responsibility of us users to be handling it. This infrastructure is totally secure as per international standards of compliances and are handled by Google itself. So the infrastructure or the underlying infrastructure that our applications is going to leverage on Google App Engine is totally secure. and that too as per the international standards. The second important contributing factor on Google App Engine feature set that contributes to security is built-in access control. Now, access control is a complete story on its own, but to keep it very brief and short for this specific webinar, we want to be telling that access control includes giving permissions. So when there are built-in access control systems, these systems give permissions for the services to access each other. So when there are, let us say, machines or the infrastructure, the database that has to communicate with each other internally, inbuilt systems on Google App Engine, they will be able to do so because of the built-in access control. The third important point is security scanning tools, which are then integratable with Google App Engine, and they contribute to security because they can scan for threats and they provide us threat intelligence, which is an important aspect of security of the web applications that are deployed on Google App Engine. So the last feature with which we wrap up this discussion of key features of Google App Engine is global reach. My dear learners, this feature is so important and such an attractive feature that attracts the developers around the globe to use Google App Engine for deployment of their applications and hosting of their web applications on Google App Engine. And this is mainly because the Google Cloud infrastructure is spread across multiple regions and zones. By this, we mean there are different geographical regions across the globe on which the data centers are present. And we can make a choice as to which data center we want to deploy our work under what circumstances. We can make copies of our work on other regions as well. Then we can also distribute our work, our solutions, our applications through Google's highly advanced content delivery network integration systems. That means there are highly advanced systems that with few very quick implementations and inputs, they are able to deliver our content, our applications to the wider audiences around the globe. And most importantly, this infrastructure that is set up around the world, which is global, this infrastructure is interconnected. Hence, there is a network of this infrastructure that exists. And this network allows easy, quick transmissions and content accesses that are needed across the globe by the users of our web applications, which are deployed on Google App Engine. So overall, we have seen that on GAE, we can leverage the four important features: global reach, security, automatic scaling, and built-in services, apart from the long list that exists and may be of use to us and can be accessed on the documentation on google.com, www.google.com, for further access. Moving forward and switching gears, we are now going to look at some practices that are adopted for getting the apps which are going to be scalable on the App Engine, getting them deployed in a very efficient manner. The first important practice that needs to be discussed is the stateless design. By stateless design, we mean that our application that is going to get requests from all other or is going to get requests from the users around the globe or the consumers of our solution. Each request is going to be totally independent and is going to be processed independently by the instance on which the copy of that application is present. So if we are having, let us say, 20 copies all together, then those 20 copies, each of the copy is going to get its own share of request by the users to access the copy, and it is going to be processed by that particular entity, that is instance itself. Another important aspect is high availability. High availability typically means having again multiple copies, and these multiple copies are then distributed to the target audiences or the target users or target consumers. So by having the multiple copies, we are able to make our solution highly available. And this feature is so very critical and such an important practice when it comes to building our solutions on the Google Cloud App Engine. The next important point is efficient resource utilization. So the resources that are being taken up as inputs for a successful operations of a given web application that is deployed on the App Engine, by adopting the stateless designs, these resource utilization come out in a very efficient manner. So taken together, what we are able to conclude is that stateless design is an important practice for building the scalable applications on App Engine. Another important practice that is leveraged is the caching mechanism. So caching mechanism means having the storage which is going to allow quick retrieval of data as and when needed. So by having the caching mechanisms in place, we are able to bypass the need to call the backend service repetitively. So this leads to improved performance of our solution, and overall the time that it saves because of high efficiency contributes to cost optimization of the operation of this solution as well. The solution that is actually deployed on App Engine for the hosting of web application, etc. So now the last important implementation that we want to discuss is the asynchronous tasks. So as we had already discussed that Google Cloud App Engine allows the task queues. Task queues means the other tasks that may have to be ongoing, maybe or maybe not in an orderly manner, to be able to handle the long running tasks without blocking the main request. That means the overall overall operations are not interrupted, and yet at the same time, side by side, the long running tasks can be they can be getting realized, or they can be operating side by side. So taken together, what we have seen is that on the Google Cloud App Engine platform, we are able to adopt the practices of stateless design. We are able to leverage caching. We are able to leverage the long running tasks running side by side without getting our main requests for the operations getting affected. So now we are going to take a look at an important question, that when to choose App Engine. So what use cases permit us to choose App Engine for our work? So the first example is web applications. The applications that experience unpredictable traffic spikes. So for example, during Christmas time, the traffic spikes could be higher, but cannot be predicted how high they will go, and hence the underlying scalability is needed, and hence the App Engine is an ideal platform for that scenario. Another example for unpredictable traffic spikes could be, apart from e-commerce application that we discussed, another use case is gaming applications. So gaming applications, which could be distributed around the globe for the business purposes, of course, and to attract the users around the globe, could also be experiencing unpredictable traffic spikes. So for example, in a given geographical location, the users of that location may access that gaming application higher during the holiday time, let us say, or a vacation time as opposed to the non-vacation time. So the traffic spikes for the web applications can get or can become unpredictable. And for those scenarios, App Engine is a suitable platform for for good experience and seamless experience of the developers. Also, there is another scenario that very well favors the use of Google Cloud App Engine, and that, my dear learners, is wherever scalable and reliable infrastructure is needed. So whenever we want the increase in resources or high availability, making copies, distributing, scaling up the businesses, scaling up the implementations on the infrastructure, which is reliable and can be, can be spun out or can be launched as and when needed for the scalable scenario. In those scenario also, the App Engine is one of the widely adopted options. Furthermore, other scenarios which permit App Engine to be adopted for web application deployment is where the priority is fast development and deployment. Why? Because infrastructure is already provisioned, and hence, if the priority is super rapid development and deployment pipelines to be in place, then because the infrastructure and management of the services is already taken care of by GCP itself, that is Google Cloud Platform itself, hence, under those circumstances also, App Engine is a preferred choice. Furthermore, having moderate data storage requirements. So when we say moderate data storage requirements, we mean that the data storage requirements are not very low. They can get higher and they can become moderately high. And that, my dear learners, is definitely the scenario for scalable solutions and solutions which need to be scaled up to accommodate the changes and the traffic spikes. So under such scenarios, data storage requirements may be moderately high, and hence App Engine is a preferred platform. Overall, the global reach and making your solution or to be able to take a web application and give it out to the world for business purposes or accessibility purposes also is another reason why App Engine becomes a preferred choice for the web application deployment and hosting. So taken together, we have seen that the Google Cloud App Engine is going to offer us a big list of features, advantages, implementations, use cases, and is an attractive platform for the developers around the globe to build applications that scale with Google Cloud App Engine. Okay, so now let's quickly take a 5-minute break, and then we will come back and discuss scalability in depth. Remember, scalability is increase in resources, and there can be different ways of scalability like manual, automatic, or basic. And we'll come back and discuss this in depth after a quick 5-minute break. Thank you.
Sure, we are now going to take a 5-minute break, but before we do that, we are going to launch a quick poll that we want to invite you to participate in. Doing so helps us know how we can better serve you by telling us who might be interested in more information or in taking some additional training. In addition, we have a lot more informative webinars coming up, so please go to netcomlearning.com/webinars in order to register.
Okay, hi everybody, welcome back from the break. Hope we all had a nice small little break. So now let's take a look into how App Engine is uh, enabling us to have solutions that are highly scalable because of its scalability features. So the list of scalability features comprises of three important ones. Number one, the automatic scaling, the basic scaling, and the manual scaling. The automatic scaling is the cornerstone of GAE's scalability. This is the reason why the developers around the world opt for the platform like GAE to have their web applications hosted and be having and get them deployed. So the GAE dynamically adjusts the number of instances, that is the virtual machines, because let us remember the applications get deployed on a machine, on the infrastructure, and the App Engine dynamically adjusts the number of machines or number of computers or number of copies of the application based on the real-time traffic. That means that internally, the Google Cloud App Engine has intelligent systems that are able to do the tuning and adjustments to check as to what is the traffic uh, need, or what is the current need, or at the need for the number of copies of the applications needed at that given time. Why would the dynamic adjustment needed? The dynamic adjustment would be needed to avoid poor user experience, because when the real-time traffic, let us say, spikes up and there is only one or two copies or few VMs or instances, then the chances are high for the users to experience latency-based issues, or even zero access altogether to our solution. So in order to mitigate that challenge, GAE permits dynamic adjustment of the number of instances. That means the infrastructure, the resource needed for our application based on the real-time traffic. So a hypothetical scenario, like when the traffic increases, the App Engine automatically spins up the new instances. So the question is going to be, how does it automatically spins up? So App Engine has inbuilt internal intelligent systems and technologies, highly advanced technologies deployed by Google engineers to automatically spin up new instances and automatically scale up or dynamically scale up our infrastructure and resources for our applications needed as and when it is needed. So also, the automatic scaling feature of Google Cloud App Engine distributes the load. That means it is going to distribute the traffic to the copies of the VMs or the virtual machine instances it has generated. So what do we mean by this? So let us say, first and foremostly, there is, let us say, only one instance, okay, in the beginning, initially only one instance on which the application has been deployed. And this instance is receiving the traffic. Now there is increased traffic surge, let us say, that is being experienced by the application. So first and foremostly, dynamically, multiple instances and hence multiple copies of our applications will be spun out. That is the first important part about automatic scaling. The second part is the distribution, who or which user or which traffic accesses which copy of the application is also internally adjusted and tuned and operated by the Google App Engine itself. So that is another important point, and this called as distribution of the load. So if there was one VM which was overloaded with traffic spikes, automatically internal systems, part of the automatic scalability or automatic scaling of GAE, they are going to distribute the load to the different machines or different copies of the applications to avoid poor user experiences. Then the automatic scaling feature also allows to maintain performance. Why? Because when the distribution of the load is done in an efficient manner, the overall performance is very well maintained. Otherwise, in this scenario where the load is increasing and there is no automatic scaling, ultimately the application is going to crash, and hence the performance is going to stoop so low and almost to negligible or nil, right? So taken together, this automatic scaling is going to effortlessly, in an automated manner, adapt to the needs of our solution by spinning up to new instances or multiple new instances, distributing the loads on those instances, ensuring the performance is maintained and the user experiences or good user experience or healthy user experience is maintained overall. On the other hand, during the low traffic period, so this is a contrasting scenario. It is a contrary scenario or situation to the high traffic spikes, right? So on the other hand, during low traffic periods, when the instances are actually not needed or the copies of the application are not needed, under those circumstances, the GAE is automatically going to shut down the instances or the infrastructure resources which are no longer under use. By doing that, the costing is affected big time. Our bills are not going to shoot up because these machines were previously needed and they were running already. So they had to be shut down because now they are no longer needed, and hence the scaling down by idling. Idling means not under use or shutting down those instances which are not under use. Also, this leads to optimization of resource allocation. And remember, optimization is a big pillar for efficient, cost-effective, and time-effective solutions to be in place. And how is it leading to optimization of resource allocation? Because it is going to internally sense automatically how many machines are not needed, how many resources are not needed, and how many resources are needed and should be up and running, and distribute the load accordingly. So there is complete optimal resource allocation that is happening behind the scenes, which again is an effortless on the part of the developer. They don't have to do this on their own, and the GAE, which is our Google Cloud App Engine platform, does this on its own by adapting and sensing to the needs like the traffic surges and the low traffic surges or the dips in the traffic surge. So now we are going to understand the next points, which are the configuring options for automatic scaling. Remember that we as users or developers or the deployers of our application have to set up a configuration through a YAML file or YAML file, if you just want to know that explicitly, YAML file which gives or furnishes the configuration options for the automatic scaling feature to be leveraged. So by doing that, we are able to customize based on our needs, on our application's needs, we are able to customize the automatic scaling behavior. So please remember that automatic scaling is one feature. Even that outcome can be customized to our application needs. And we do that based on the configuration options that we ourselves set up. So one example is if our runtime is Python, so in the YAML file, our configuration option setup is going to be for the Python. If our runtime and our language that we're using for application is, let us say, Java or Node.js, then accordingly the configuration settings are to be done in the YAML file. So the runtime that is going to be defined is going to be Node.js. Apart from runtime, there are other configuration options as well that are important inputs for the automatic scaling. Another option of configuration settings for the automatic scaling or automated scaling behavior is to be able to scale based on request rate. That means how many requests per second are coming. Request means the users who are trying to access our web applications over the internet. So that request rate is tabulated and it is sensed internally. And to get that request rate sensed, and this has to be then present in the configuration settings. So automatic scaling feature is available. Let me show that again. Automatic scaling feature is available, and big time it is helpful to the developers, but it needs the configuration settings from our end that need to be furnished, and only then this feature can be leveraged. That is the point we want to be making up. And then we also want to know that configuration options are also going to be related to the latency based aspects. That means we want to scale up our resources, our infrastructure, our machines for our applications on response latency. That means how long it takes to respond to requests. So longer it is taking to respond to the request, that means higher the traffic is and the experience of the user is getting poorer and poorer. So then it is going to quickly sense that internally and launch the multiple copies and do the load distribution so that it is taking less long, not very long, but less long to respond to the request. So latency is another factor that is going to be considered when the configuration options are being set up. Another important consideration is the custom metrics. So custom metrics like CPU usage or memory usage. Remember, we discussed in the previous slides that metrics are related to monitoring of the service. So the GAE, Google App Engine, is getting monitored through the monitoring services within the GCP environment itself. So these monitoring services are generating the metrics. So these metrics are constantly internally being studied through the feedback loops, and these metrics are then directing the configuration settings, or maybe valuable to decide the configuration settings for the automatic scaling or automated scaling feature to be leveraged. So overall, what we are trying to say here is that the automatic scaling feature can be leveraged if and only if configuration is done accordingly. What are the aspects that have to be considered for configuration? Number one, the needs of the application. Number two, the request rates coming per second. Number three, the latency issues being faced by the stakeholders, or the latency issues being posed or being experienced by the users and their request that is coming. And also the monitoring data is again going to give the outcomes like CPU usage, or let us say the CPU usage is spiking up CPU usage of what? Of the machines on which the application is deployed. Then accordingly, new automatic newer end resources may have to be launched, because otherwise the experience may go poor. Similarly, the memory usage is very high as being informed by the monitoring data, right? Then if the memory usage is very high and the monitoring data is reporting that, then the automatic scaling needs to be done to generate machines, so that this should not affect the user experience overall. So taken together, there are the automatic scaling behavior can be leveraged, can be experienced only if the correct configuration options and the settings are in place, which in turn is dependent on many factors as we have discussed just now. So moving forward, the last configuration option factor for automatic scaling is the number of minimum instances. So for the, let us say for the cost optimization reasons, it is always a good practice to specify a minimum number of instances to keep running even during the low traffic periods, so that you have the application up and running and there is zero downtime. So taken together, the first feature was the automatic scaling as part of the scalability provisions done by Google App Engine for its users or for its developers who are trying to use it or leverage the scalability setup on the Google App Engine. The second feature, apart from automatic scaling, is the basic scaling. But this basic scaling is adopted under very peculiar use case. For example, when you have bursty traffic patterns. Bursty means like booms. In just a brief period or duration, the traffic may spike up, but that spike is not regular and consistent. It is rather inconsistent and quite unpredictable and bursty. So in that case, it is the setting that is quite helpful. Again, just like your configuration settings that have to be done for automatic scaling, accordingly, for if you want to set up basic scaling instead of automatic scaling, you have to set it up through the configuration settings only. And in the exact same manner as we discussed for automatic scaling, configuration settings are done through the YAML files, and same way even basic scaling settings are going to be done through the YAML or YAML files. And the good news is we will be practically seeing what these files are and how they look like, etc., in the demo which is going to follow this particular section. So just wait for a bit and we are just getting to a quick demo to see what these files look like and what these settings are all about. So to quickly talk a little bit more about basic scaling, this aspect involves that an instance is launched for each incoming request. That means as and when the traffic patterns become bursty, every single time the request is going to come, a fresh new instance is going to be launched. Why? Because there needs to be a system in place that even if the traffic goes bursty, there is not going to be dearth of copies of applications, and hence the user experience is not going to suffer. So for each incoming request, the instance is going to be launched, but that is not going to be the case for the automatic scaling. Because for automatic scaling, there could be many multiple requests that could be channeled to one given instance. It is not that every time request is going to come, one instance is going to come. But for your basic scaling, when such surges are totally unpredictable and they burst out, in that case, just to be safe, then the safe from what? Safe from having zero downtime or poor experiences and high latency issues or high timing for the system or machine to respond to the user request. In that case, to avoid all that, instances are launched one after another for each incoming request to accommodate the bursty traffic patterns. Also, once the search has gone, so we are talking about now, typically it has suddenly become very low, and hence the instances have become idle because there is no traffic. Then automatically they're going to get shut down after a period of inactivity. And also, when such scenarios of unpredictable traffic surges, as we've already discussed, are followed by lulls, or lulls is like the low traffic, and there is constantly spiking up and low, spiking up and low, like that. When such pattern is observed, then the basic scaling is quite adopted practice in the developers or across the developers community. So now we come to the third and final feature in the scalability story of the Google Cloud App Engine, and that is manual scaling. Manual scaling is going to permit us having a very granular control. Granular means very fine grain control. Fine grain control means we are able to very precisely and exactly decide how many instances should only be launched, only 5 instances, only 3 instances. And by having such fine grain control, we do the configuration settings accordingly, again in the YAML file. But by doing that, it is giving us better control, more and more control over the number of instances. And why would we like to put this effort when already an amazing automatic scaling is going to be in place? This effort we could put only when we are really tight on budgets and we just want to be limited to very few instances and very, very specific number of instances and not even go beyond. Hence, we would like to go for manual scaling. So we define the exact number of instances to run continuously and nothing beyond that. So if the traffic surge is continuing to be very, very high and the number of instance threshold has been met, let us say 5 instances, then what is going to happen? Are more instances going to be launched and scalability is going to be there? No, because the setting is manual scaling. Hence, the developers don't risk that, and hence it is used less frequently. Because what if it becomes bursty, or what it becomes there is a traffic surge? So only and only the circumstances where you are sure about the traffic's rate, and you have good idea about traffic rate, and you have good idea about not risking and not going beyond a given traffic rate, only then you are able to gauge the number of instances that would suffice for your application to be running and being available with the continued performance and zero downtime. Hence, it is used less frequently because sometimes it is not possible to gauge that in advance, and hence the automated scaling or basic scaling is a preferred option. So overall, as discussed, it's a less common approach, and it is generally preferred for its flexibility because you can quickly go back, change the configuration files, and you can make, previously you had 2 instances, now you can make 3, 4, but you will still have good idea that what the traffic rate is going to be for your application. And also it is suitable for specific scenarios with predictable, like we already discussed, you know the traffic rates and the resource requirements that would be needed for your machine or for your application, or the machines that you will be needed for your applications, or the number of machines needed for your application. So taken together, we have seen the 3 important kinds or categories of scalings available as the scalability feature set of the Google Cloud App Engine. Number 1, automatic scaling. Number 2, basic scaling. And number 3 is the manual scaling. Let's practically experience the Google Cloud App Engine through a very simple example. And let's see through a very, very simple example. And let's see how we can go about, getting the application deployed, and how we go about working with the Google Cloud App Engine. So coming to the first important point to take a look at the project being set up, because without setting up the project, no work and no task can be executed in the Google Cloud platform. So this is the first mandatory input that needs to be there. After confirming this, the project setup being done, then we come to enabling the APIs. So we want to be enabling the API, which is our Google Cloud App Engine. So we want to type here App Engine. And once we are able to enable this particular API, we are good to move forward with the work on the Google Cloud App Engine. So now we want to go ahead and make the deployment of our application, which has been developed already. And this development part is not our agenda, but few important points about the development is important. Like, for example, what are the bare minimum inputs needed at the stage of development itself, so that the application can be deployed on Google Cloud App Engine. So that discussion about development is important. But we are not having a programming class here, so we are not going to get into the programming story or in-depth development, but we're talking about from the cloud native perspective, what development points need to be there. Okay, so let's come to our GCP. What you're seeing on the screen is a Google Cloud platform console in which the project has been set up. The API has been enabled, or the Google Cloud App Engine API has been enabled. And I'm refreshing this so that we are able to get started with our work. And we are launching our Cloud Shell to be able to operate and do the work using the command line method of interaction. And for the command line method of interaction, we are going to write the commands to be able to execute our work. Any deployment of the completely prepared and developed application in the Google Cloud App Engine will be done through command line method of interaction, and provided that application is already ready and has been already prepared and tested in its in the local environment, be it your laptop, desktop, or your servers. But once that is ready, then it can be deployed to Google Cloud App Engine. So let's do that. So we are still waiting for this to become active, Cloud Shell. And there is a set of commands that we will be using to begin the work from scratch. So the first step is to set up the Cloud Shell, give the right authorizations, set up the region and the related details. So let's take a look at the commands for the same. So we go back and we have it written down on the side. The first one is our gcloud auth list, and through this command we are going to do the listing, or we want to be looking at the authorizations, whether they are in place or not for this particular account and the project. And we see this, that for this particular account, it is there already. It is authorized. So that is an active account. Account of what? Account of this particular GCP login that is being used. Then we have to quickly do the project check, whether the project is active in the system or not. So to do that, we want to see that yes, the project is this and this is the active configuration. Once that is done, we are going to double check, but let's double check the project name, because the project name has to match with whatever is set up over here. So it's GCP 01FF34922A242D, and this is FF34922A242D. Okay, so that's fine. So now we're in the same project as this, and there's a synchronization. All what we're going to do through command line is going to sync up in the graphical user interface as well. Now once that's done, we are all set to then set up the region, and that region is going to be the one that needs to be set up is US Central 1. Now that is already existing, and by default it is set up at the time of the launch of the lab. Let's go to the next, which is we now want to get our code. So this code we are importing from an open source repository, which is the GitHub repository. The aspects of this code that we need to be careful about is that what are the inputs needed to be in place for App Engine deployment. So YAML file, remember when we were on the discussion of automatic scaling, basic scaling, manual scaling, YAML file discussion had come up. So that needs to be in place. So let's dive into the exact folder using the cd command to get the access to the exact files needed. So in the previous command, I've used git clone to be able to get the complete or clone the repository from GitHub. And the name of the repository is, let us say, Google Cloud Platform Python docs sample .git, right? And this has been now brought into this environment. And now what we're going to do next is we're going to first check, let us say, for example, let's not do this. Let's do a quick check using the list command to see whether the folder is present. Python docs samples. This has been Python docs samples exact repository that we wanted to download or obtain or bring into our environment, or in other words, clone over here. Once we have done that, now we are going to go to a folder named as Hello World. And let's come to this folder using the change directory command. And now we can see that we are in a folder named as Hello World. So you see the complete path is changing over here as opposed to here, right? So now we are inside Hello World. If we do a list, we will be able to see the files present. And here we see app.yaml. So this is the file which should be having the configuration details. So this file, if it is present, then our configuration details accordingly should be present as per our needs, but we will go according to whatever this open source example is offering. So what we have done is we have enabled App Engine. Now App Engine is good to go and get our application deployed with the right protocol. And the protocol needs, first of all, it needs the code with the right set of files. And you can see the code has been imported from the open source repository by cloning it or cloning a repository in this environment. And if we try to access the YAML file, nano app.yaml, so at the development stage itself, this file, let's have this, this is app. So at this stage itself, at the time of getting the YAML file ready itself, it needs to be declaring the runtime. So once the runtime is declared, accordingly, it is going to implement the default auto-scaling setup for this runtime present in Google Cloud App Engine system. So let's quickly deploy the application and review what scaling feature is present for this exercise that we are going to do. So the app.yaml file is present in our code repository, so we are good to move forward. Now let's see what are the next steps to have the application deployed. So the code for the application is ready. We have main.py file, we have app.yaml, we have dependencies. If we go back and take a look at the list, we have dependencies, requirements that are going to be needed, or the dependencies needed by the code to be deployed. And if we quickly go back and check other files like main.py, main_test.py, they're all parts of the all set of inputs needed for the application to be deployed on Google Cloud App Engine. So YAML is going to give configuration, requirements is going to give uh, the dependencies that are needed, etc., so on and so forth. Now we want to deploy this application. So the command to deploy the application on the Google Cloud App Engine is gcloud app deploy. So we have it here, gcloud app deploy. And in the process of deployment, it is going to ask us, where do you want this to be deployed? US Central 1 is what we want, and that is number 10. And the reason we have chosen this is because the setting of this particular lab is for that particular region. So we have to go by that particular setting itself. So in the cloud fundamental sessions, we learn about these regions and zones. So there's a prerequisite, and we are assuming that learners have some experience and some background in Google Cloud Platform, some fundamental knowledge, and there you learn a lot in depth about regions and zones. So here for the deployment, we are choosing which data center in which geographical region we want, and the choice is US Central in this particular example over here. So this may take a little bit of time for the deployment to go through, but once the deployment is done, we will then browse our app which is already deployed. And after deployment and after browsing our app through the browser tab here, we will then go back and review the configuration. What scaling feature it is already adopting and what scaling feature is already in place. So by doing that, we will be able to have a review of the settings that are being implemented on this particular application. And likewise, the learners, when they go back and they deploy their own application with the YAML file, providing the details accordingly, then they can expect the App Engine to adapt to that configuration and have the scaling system accordingly in place. So let's wait a little bit more for this to get completed. So the next step, we want to browse our app that has automatically been deployed. So look at the power of App Engine. Internally, all systems are now operating the asynchronous tasks, the memory caching, the logging, reporting, the monitoring, complete deployment, and also the URL generation for the app or the web app that is now deployed on the web. So we're going to quickly have this accessed and generate the URL. And we see that the URL has now been generated. This URL we are going to access through the browser, and we will see that our Hello World application has been deployed on the internet. And let us try to have this access through multiple times. Just we're trying to add some load on this particular system and to just quickly go back and gauge. Now this application is readily deployed. Now we are going to the App Engine dashboard, because App Engine dashboard is going to give us the details about this particular application that is deployed, the running of this application, and the details we can fetch over here. So the main dashboard is going to give us the URL that we already have. You got it here as well. And the left panel, the services, versions, instances are going to empower us with the information about this application that is deployed. So if we go to the instances, right? So it is showing us that this is the name of the instance, this is the machine, this is the computer on which this application has been deployed. And remember, this is provisioned internally through Google Cloud App Engine because it is a managed service, it is a platform as a service. Infrastructure is already taken care of. So if I select this and I scroll to the right, it is telling total of 3 requests as of now. If I refresh, it may give a different number because it takes time to sync up. And it is also showing the time it is taking to respond. So every time the URL is going to be added or provided in the browser tab, it is taking up to 332 milliseconds for the user to get the response. Now, if we go to the right side, we are able to see that there is a dynamic availability present over here. So that means by default, it is picking up the settings for dynamically scaling up. So we're looking in the direction of automatic scalability by default. If we want to go back and change the scalability scenario, then we will have to go back and make the edits to the YAML file. So using the right syntax, right protocol, and the right inputs of the commands, we will be able to change the YAML file and have the differential scalability experience. Here, the default settings are the automatic scaling, and we can see there is only one VM for the 3 requests. Remember, it is internally intelligently sensed by Google Cloud App Engine how many more requests are going to be needed before a fresh new copy of the VM is needed. But when you have those bursty spikes, right, there where you have basic scaling, in that case, every single request that we will be having, a fresh new machine will be launched. But that is not the case over here. Over here, we are saying there's only one machine, as you can see over here. And this machine is going to be, is already accessed by multiple requests. And it is good to go, no issues, no major latency issues coming up as of now. And the automatic scaling is the default setting which is in place. Now for this particular one that we have now, we can go back and go to versions, and we are able to see that as of now, there is only the first version of the application that is deployed that we can see. And this is talking about the service account, let us say, for example, which is the service account is part of the access control, inbuilt access control, the permission setup. So this is the working entity and the entity in the direction of access control. And here we can now take a look at the configuration settings of the scalability. As my learners can see on the screen, this default settings of the YAML file that we use, where we only specify the runtime, automatically is using the default scalability feature, which is the automatic scaling. And this YAML file snippet, if you don't put it explicitly, automatically in this particular system it is generating, but sometimes you may have to provide this information explicitly. So shown here is the exact syntax, how the YAML information is going to be entered typically in this example for automatic scaling feature. Another important point that needs to be remembered is this instance class. Instance class is the machine, the computer, the VM, virtual machine instance on which the application is deployed, all happening automatically internally. We only provided the code which was having the right set of files. That's it. So once we provided that code that had the right set of files, we were all set, and internally Google Cloud App Engine is going to handle complete set of inputs needed for complete deployment, including infrastructure, including memory caching, asynchronous tasks, everything it is going to handle on its own. It is an automated platform, fully managed and platform as a service. So that is the beauty of using the Google Cloud App Engine. So coming back to instances, so the instance that was used over here is instance class F1. So it is a determining factor which type of instances are compatible for which kind of scaling feature. So your automatic scaling very well is compatible with the F1 instance type. And these different instance types have their different CPU configuration, storage configuration. So configuration of these machines are different, but F1 is typically used here and is showing up here because it is compatible with the automatic scaling feature type. It is also showing that this configuration will get maximum of 5 VMs. So as the traffic is going to search for this application, more and more requests are going to come. Then the newer VMs will be launched. When will the new VM is going to be launched? After like, let us say 10, 20, 100 requests that internally Google App Engine is going to decide based upon the latency and other factors, and there are intelligent systems. But one thing is for sure, that a maximum of 5 instances and nothing beyond that is going to be launched. So if then the bursting happens, then the experience of the users is going to get affected and the performance is going to get affected. And if the bursting is experienced, then this is not going to be applicable. Then the YAML file will have to be changed for basic scaling, and then it is going to handle the bursting accordingly. With this, everybody, we come to an end of a small little walkthrough and some simple general idea about App Engine, about how the code which is being prepared and the set of files which are needed, the requirements file, the main.py, also the apps.yaml needed, and how the YAML configuration, which has the information being given out related to the type of scaling feature. And we have the automatic scaling feature set up over here, as we can see, and accordingly the instances which are going to be spun out for the to leverage the scalability aspect of the Google Cloud App Engine. With this, everybody, we are moving to the last discussion in this small little journey that we had together, and that is to evaluate your own use cases and then with prudence make the decision about whether we want to be using Google Cloud App Engine or not, or whether under given circumstances Google Cloud App Engine is suitable for our use case or not. So in that direction, before we summarize, let's quickly have this evaluation taken care of. So first and foremostly, you need to check the programming language support. So the runtime that you want to be using should be supported. So the example that we used here was the Python, and that is very well supported. Likewise, Ruby is supported, Java is supported. So you have to go back and check whether the language that you are using, whether it is supported or not. The second is your database needs. So check whether the data storage requirements are compatible with App Engine Data Store. So App Engine Data Store means when you have your application and application needs the database, will it be compatible with the App Engine Data Store typically? So this is kind of NoSQL or non-relational database. So the relational database App Engine suitability has to be figured out in different ways, but direct App Engine database suitability or compatibility with the data store, which is NoSQL or non-relational database type or data non-relational data information can be stored. This is very important evaluation which cannot be taken for granted come what may. Okay, then we have to go back and take a look at checking integration with external databases. If your application needs to be integrating with external databases like relational databases, like SQL based databases, then your code snippets should be accordingly, and your code should be able to support that very well. Other checks that needs to be done is the scalability requirements that we've already discussed, which kind of scaling, what kind of traffic predictabilities, whether you have or you don't have, etc. So what kind of traffic anticipations are possible and feasible in the solution that you're working with. Accordingly, scalability requirements, accordingly YAML configurations. And then the budget constraints. So pay per use model is whatever you are going to use. Whenever it gets terminated, the billing is not no longer going to be viable for that. So then once your use is over and your application is still running, then your billing cycles will be on. So you have to remember to terminate when you don't need to have your application deployed any longer. And then the operational complexity, very important. You have to check whether you're comfortable with a managed environment or you require more granular control. So if you're okay with managed environment, your PaaS, your Google Cloud App Engine is good. If you need to be launching your infrastructure yourself, very, very tight control on your infrastructure, then you will have to go for Compute Engine and not for Google Cloud App Engine. And Compute Engine is not the matter of discussion here in this session. It is the Google Cloud App Engine session. So with this, everybody, we come to the end of session today, and we would like to summarize the points that we have talked about. We've talked in depth about Google Cloud App Engine being a very powerful platform to support web applications and deploying scalable web applications. It offers us robust infrastructure, all automated, fully managed by Google. We just now saw that. We just deployed the code with few commands. Rest everything was handled internally automatically. And we also saw automatic scaling on the screen. And also we saw that this set of deployment on the left panel, we had a lot of features we could explore, like versions. We could explore details about instances, etc., etc. And overall, this platform is ideal for developers who want to focus on building great applications without worrying about infrastructure. With this, everybody, we come to the end of session today. We would like to thank our learners for their precious time, our deepest gratitude for their amazing synchronization and cooperation. We would also like to pick up some questions.
Thank you, Geetika. That was most informative. Now, I know everyone's looking forward to the Q&A session, so go ahead and start putting your questions into the questions panel. And while you do that, I'd like to give the presentation rights over to Ifla, our product marketing person, who's going to introduce you to some of our fantastic promotions and webinar-related courses.
Thank you, Tracy, and thank you, Geetika, for this insightful session. I believe everyone must have learned something new today or would have been able to brush up their skills around Google Cloud technology.
So firstly, I'm excited to announce that Netcom Learning is now an authorized training partner for Google Cloud, making us your go-to destination for cloud skilling. With this milestone, we are proud to offer comprehensive training across the three leading cloud technologies globally: Microsoft Azure, AWS Cloud, and now Google Cloud. So we, Netcom Learning, is your one-stop shop for cloud skilling. I would also quickly like to take you through some of our hand picked resources, which we think will immensely help in accelerating your Google Cloud skilling journey. Well, this document here that I'm presenting has been shared with you all in the handout section of GoToWebinar panel. You can download this document and access all the resources and browse all the offerings we have curated for you. So first up is the list of our recommended courses, which we feel will best suit your learning journey after attending our masterclass. So all these courses here are hyperlinked. Feel free to go through them post-event and check out the course descriptions and prerequisites and the value it can add to you and your team skill sets. Additionally, we have curated a blend of resources, including our upcoming and on demand events, as well as some informative and educational blogs. So you can make the most of these resources to gain extensive knowledge on the Google Cloud topics they cover. Now, next up, we are offering Google Cloud Fundamentals course, which is usually priced at $575, but we are offering this absolutely free of cost. So this is the full one-day course in which you and your teams will learn how to use Google Cloud services and tools effectively and gain a solid understanding of the core components of Google Cloud platforms. You will also get hands-on practice through practical labs, allowing you to apply your new skills right away. So this is a full day course, unlike our masterclasses and webinars. So we have limited seats available for this, and you can request enrollment by clicking here on this button. So submit your registrations to us as soon as possible, and our team will get back to you with the confirmations. Uh, Also, here I would like to inform you that today's masterclass session is being recorded. So, in case you want to refer back to any of the topics that were covered by the trainer today, we'll be sharing the recording link with you through emails, and also you can access the link here on the handout so that you can revisit the session and learn at your own pace. Now, apart from our virtual sessions, you can also catch all the relevant updates related to IT and business training on our social media handles. So please feel free to follow us on LinkedIn, Twitter, and Instagram, and also subscribe to our YouTube channel for all the latest updates. Our official pages and channels are linked here on the icons. Finally, if you have any suggestions regarding the topics you would like us to cover in our upcoming webinars and masterclasses, please don't hesitate to send us a direct message or leave a comment on our social media posts, or you can just simply email us at google@netcomlearning.com. We would definitely try to come up with the sessions on your suggested topics. Thank you once again for joining us today. You guys have a good one. Thank you.
Thanks so much for guiding us through that information, Ifla.
And now we're going to go ahead and jump right into our question and answer session.
Our first question of the day is, how is App Engine different from Compute Engine in GCP?
So App Engine gives you fully managed infrastructure. You don't have to launch the infrastructure. But on the Compute Engine, it is we ourselves, we decide the compute resources and the infrastructure that we want to launch. So when we want to be having fine grain control or fine control over the infrastructure and the needs are very customized and very specific, then we go for compute engine based deployments as opposed to app engine. But majorly app engine, because of its all automations and everything provisioned inbuilt services, database integration, then that is the preferred choice by far for most of the web applications. Next,
let's take another question. What storage services connect to the App Engine in GCP?
as we've already discussed in the class, storage services like you have your object storage like your buckets, they would integrate. Your data store database for NoSQL or non-relational database service, that is going to integrate. Likewise, as long as you have the cloud native code present, you can integrate with other services as well. But there is a proper code implementation that needs to be done. So this has to be handled with the experts and the software developers on the cloud DevOps, with cloud DevOps expertise typically.
Our last question is, can you share some examples of runtime environments possible in App Engine?
We've already talked about this runtime environments. We have, like, for example, Python, we had Node.js, and there is Java also possible on this Google Cloud App Engine.
Once again, I want to remind you that as you leave the session today, you will be presented with a short survey. We would like to request for you to help us by taking a quick moment to participate in that survey. Your feedback really helps us understand your learning experience as we are constantly looking at how we can improve our future sessions. The survey answers are measured on a scale of 1 to 5, 5 representing outstanding and 1 representing poor. We want to thank all of you for joining us today, and if you do come up with any additional questions, feel free to send them to webinar@netcomlearning.com at any time. We hope that you found today's webinar informative, and we look forward to seeing you back here with us soon. Feel free to tell your friends and colleagues about our webinars and other courses. Have a great day, everyone.